Hello everyone, welcome to today's tutorial under the title of Data Modeling. So before we understand what is data modeling, I would like to have a quick recap on tutorial 5 where we discussed databases and the many tables inside them, where each table had rows and columns, and we called the columns attributes. And as this table has two dimensions, rows and columns, we called it a relational database. Okay, we also discussed a system or a tool that's called Microsoft Access, and we used it in order to deal with the data. However, as an introduction to business informatics student, we have been discussing throughout the semester that you're unique as a student, which means knowing how to use a system or a tool in order to deal with the data is not enough, as everyone else can do it. I mean, if you brought a student from any other major and you just taught them Microsoft Access, they will be able to deal with the data in less than hours. So, a business informatics student is required to know more details about databases, to the extent that you're required to know how to design and implement a database. And designing and implementing something means that you need to understand the business side and the technical side, which is also a feature in the business informatics student. In order to do so in databases, just like in everything else, you need to understand the database both on the business side and the technical side. So understanding the business requirement or the logic behind creating this database is known as conceptual level. While if we started translating this requirements or logic that we thought of or the relationships that we created into codes and an actual system, this is called the physical level. You're actually going to take two database courses in the university, but you're not going to take them any soon. You're going to take them in the third year in more details, both on conceptual and physical level, using programming language such as SQL. However, we're not going to discuss this in Introduction to Business Informatics course or in this tutorial. What we care about today is that we are going to cover the basic concepts on how to design a database on conceptual level. So, conceptual level, it means that we're going to think about the logic or the business analysis. So, what's going to help us doing something like this is something called ERD, which stands for Entity Relationship Diagram. So let's start. Remember in the past tutorial when we discussed that databases integrated the tables together in order to have better communication between different departments, and the example of McDonald's that we gave where we changed the data in one table and then it's reflected on every other tables. So this means that a database establish a relationship between different tables. So in order to be able to design a database, it's very important to understand the relationship between these tables and how they work together in updating, deleting, and so on. So there is a diagram that helps us understand this relationship in order to be able to translate it into codes later on through different steps. And this diagram is called Entity Relationship Diagram. It's called Entity Relationship Diagram as the word entity reflects the table in the database. So, in general, Entity Relationship Diagram is used in designing the databases, and it's used in designing it on conceptual or logical level, as we're not doing anything technical now, we're just thinking about the relationships and the logic behind implementing it. It's okay if you don't really get what does a relationship mean and so on. We will actually learn how to draw an entity relationship diagram. By the end of the tutorial, everything will be clear. Okay, so entity relationship diagram is the highest abstraction of data modeling. So what does this mean? It means that it's the less detailed of designing, the less detailed model of modeling a database, or the simplest form of it. So if you really want to design and implement a database, the simplest form or the first thing that you need to do is creating an entity relationship diagram. Okay, again, from its name, it represents the relationship between different entities or tables in a database. So what are these relationships? Or what are the kinds of relationship that we can have between different tables or different entities? We have mainly three types. The first one is one-to-one, one-to-many, and many-to-many. I know it's a bit confusing, but throughout the tutorial, you're going to grasp everything. So let's have an example on what kind of relationships can we establish between different entities. So before going into details in the relationships between entities, I want you to understand the entity relationship diagram. Any diagram in the world have some symbols that represent something. Same goes for entity relationship diagram or ERD. So first of all, if we drew a rectangle, then this means it's an entity or table. You actually have to know the shapes as you're going to be required to draw this in the exam or assignments or whatever. Or later on in your life if you saw a rectangle in an entity relationship diagram, so you have to know that this represents an entity or table. Okay, so we said that each table in the database have a column or many columns, and we call them attributes. These attributes are represented by this shape. It's kind of oval, so please don't draw it as a circle. Okay, we said that there are relationships between entities, and the three types are one-to-one, and it's a straight line, so that this straight line will go from one entity to another, as the relationships are always between two entities. And the other type is one-to-many, one-to-many. So the one is looks like a single line from this side, and the many side is always looks like a fork. So definitely, as we said that the many side looks like a fork, so a many-to-many relationship will look like a fork from both sides. Okay, so now let's have a business example so that we can understand how to draw an entity relationship diagram in order to start modeling the data. Okay, so the example that we have in this tutorial is designing a database for an airline company. And this airline company provided us with some business details that you, as a business informatics student, must understand them and be able to transfer these requirements or business needs into an entity relationship diagram so that you can later implement the database. So let's go through these requirements and see how can we translate them into an entity relationship diagram. So the first one says a pilot can only fly one plane, and the plane can only be flown by one pilot. So if you really want to represent this statement in an entity relationship diagram, the first thing that you have to do is thinking about what entities do you have in this statement, or what tables can you create in a database from this statement. In my opinion, I think a pilot could be an entity, and a plane could be an entity or a table. And I can imagine that each pilot or table representing the pilot as an object or as a person will have columns describing the pilot, such as the name, um, the license number of this pilot, and so on. So there will be many columns to describe the pilot inside the pilot table. I can also imagine that in the plane table, or the data about planes, will contain columns that describes the plane ID, for example, type, and so on. So that's why I concluded that pilot and plane could be separate entities or separate tables. So once you identified the entities inside this statement, the second thing that you need to do is thinking about the relationship. And always keep in mind that you have three types of relationships: one-to-one, one-to-many, and many-to-many. So in this statement, it says a pilot can only fly one plane. So this is one side of the relationship. The second side is a plane can only be flown by one pilot. So this is the second side of the relationship. So you can conclude that it's a one-to-one relationship, as in both sides only one instance can do this action. Okay, it sounds a bit complicated, but let's take an example. So you can start doing the same thing for all statements or business analysis requirements, and identify the different entities. So the entities in all statements are highlighted in blue, or the tables that we're going to create in the database, and the type of relationship, whether it's one-to-one, one-to-many, or many-to-many, is highlighted in red. So this is a one-to-one relationship, this is a many-to-one relationship, and so on. So let's see how can we draw something like this. Okay, so the first thing that we need to do in order to be able to draw an entity relationship diagram is identifying the entities uh, from the business analysis. And in our example, the first statement in the airline company says that we have a pilot as an entity or a separate table in the database, and we have the plane as an entity or a separate table in the database. So we start drawing a rectangle like this, and right inside it pilot, and we draw another rectangle and right inside it plane to represent this table. So we said that the next thing that we need to do is identifying the relationship between both entities or table. In the first statement in the requirements, we said that every single pilot can only fly one plane. So this means that the relationship in this side is going to be 1. From the other side, or the relationship of the plane to pilot, it's as well a 1 relationship, because every single plane is flown by a single pilot. So that's why it's a 1-to-1 relationship. The one-to-one relationship, or one-to-many relationship, or many-to-many relationship is known as the cardinality. So if you saw the word cardinality in any exam or assignment or later on in your life, you have to understand that it means what kind of relationship is associated between different entities in the entity relationship diagram. Okay, so we discussed the first type of relationship, which was a one-to-one relationship. Now we need to select a statement from the requirements of the airline company that represents a one-to-many relationship. An example of this relationship could be the statement that says each single route is assigned to many flights, which logically makes sense, as many flights can go, for example, from Egypt to Germany. It's okay. However, a relationship has two sides, and the other side of the relationship is flight to route. So the flight to route, each single flight can only fly at one route at a time. You might think that I might book a flight from Egypt to Germany and then from Germany to the United States, but this is considered two flights, and that's why you can only go at one destination at a time. Like the plane can't copy itself. So that's why the relationship from flight to route is a one relationship. So when you always think about where should I draw the fork, here or here, or it's a one-to-many relationship, or how can I do this? If you start saying flight, then to route, then you draw the relationship on the other side. So the entity that you called first, you draw the relationship on the other side. So from flight to route, it's a one relationship, and from route to flight, it's a many relationship. Okay, let's have the next example on the final type of relationships, which is many to many. Okay, so we're going to pick a statement that represents a many to many relationship from the previous slide. The statement could be that passengers can take many flights, and that's why we drew a fork on this side, which makes sense. You as a passenger can book many flights, one to Germany and then you're going to travel to Spain. And every single flight can be taken by many passengers. So that's why we drew the fork on this side. I hope you understood the relationships between each entities. In the next tutorial, we're going to have a practical assignment on this, and you can also Google many entity relationship diagrams in order to better understand the concepts. It's sometimes confusing, but however, if you thought about it according to what's written in the requirements, it's going to be pretty easy. Just think about the entity and then the relationship. Every single entity and then the relationship, sorry. Okay, let's move. Okay, so these are the requirements of the airline company, all of them. If you try to translate everything written in this requirements and identifying the entities or tables and the relationships between them, which are highlighted in red, into an entity relationship diagram, we will produce this shape of entity relationship diagram. So let's go through the entity relationship diagram in order to grasp the concept of creating tables and entities and the relationships between them. So the first statement is the pilot or every single pilot can only fly a single plane. So let's search for the pilot. Yes. So this is the entity pilot. We drew a rectangle, and then the relationship that is that the pilot can only fly one plane. So we drew a single line on the other side. Okay, the other side of the relationship, as we said, each relationship between two entities has two sides. So the other side is that each single plane can only be flown by a single pilot. So we drew the line on this side. We did this example before, so let's take the next one. Every single plane has many seats. So if we're going from the entity plane to the entity seats, the fork is going to be on the entity seats side. So let's check this in the diagram. Okay, so Here is the plane, and these are the seats. A plane has many seats, so that's why the fork is on the other side, because we started saying plane and we drew the relationship on the other side again. Okay, so the other side of the relationship. Each each single seat belongs to only one plane. A seat can't copy itself and exist on two planes at the same time, meaning if we have this specific chair and you dropped a hot chocolate on it, it cannot be dropped on every single chair in any other plane because this seat is unique. Okay, so each single seat can only belong to one plane. I don't want you to think about seats as all of them. I just want you to think about a single seat inside the plane. So a single seat can only exist once inside the plane. So that's why the relationship is a one relationship. Let's have another example. A flight has one plane, but a plane has many flights. We took this example, so let's skip this. A flight is shown in only one schedule, but a schedule shows many flights. So that's a one-to-many relationship. Let's see this in the entity relationship diagram. Flight and schedule. So if we started drawing the relationship from schedule to flights, definitely each single schedule contains many flights. As we started saying schedule, so we drew the fork on the other side. And then the other side of the relationship between these two entities is that each single flight is only shown in one schedule. So that's why we drew a straight line on the other side. Okay, let's take this example for instance. A reservation is made by only one passenger. So the first entity is reservation and the second entity is passenger. And the relationship is one to many. So how can we draw this? We start drawing a rectangle and right inside it reservation, and then we draw the other entity, which is the passenger, and right inside it passenger, and then we start identifying the cardinality between them, or the relationship between them on both sides. So the first side is one reservation can only be made by one passenger. So each single reservation can only be made by a single passenger. I'm not talking about reservations in general, I'm talking about a certain reservation. For example, as a reservation with certain number. So the other side of the relationship is passenger to reservation. You can make many reservations. For example, you're going to reserve 2 flights, 4 flights, 1, whatever you want. So if it's 1 or more, then it's a many relationship. So each passenger can make many reservations. So that's why we drew the many or the fork on the reservation side, because it's going this way. I hope it's clear, and if it's not clear, we're going to see another example in the next tutorial. So, in order to design a database, it's not enough to understand the relationship between the entities or the tables inside the database. We also need to understand the attributes or the columns inside each table, as they have different types. So the example that we're going to have in order to understand what does different types of attributes or columns inside the table means is the student table. So imagine that you have a two-dimensional tables with rows and columns, and this table is describing students, you as business informatics students, for example. So I can imagine that the columns or attributes or features describing you as a student could be your ID, 49 dash, and then your ID, your email address, your name, whether it's first or last name, and the date of birth. So these are the columns or the attributes, and as we said, they are represented by an oval shape. So if you want to draw the attributes in the entity relationship diagram, as we said, the entity is represented by the rectangle, and then the attribute is represented by the oval shape. We connect each column or attribute to its table or entity through a straight line. Okay, so let's see what those different types of attributes mean. First, we have a normal attribute. It's any attribute with one value. For example, your date of birth. You're born at 1st of January 2001, for example. It's just one value. You don't have two birthdays, for example. Okay. The second type of attribute is called composite attributes. Composite attributes is basically any attribute that can be broken down into smaller attributes. What does this mean? An example of this is your name. Your name can be broken down into first name and last name. What else can be broken down into other attributes or smaller attributes? For example, if you're filling form and this form wants your address. So your address could be an attribute, and then we can split it into further smaller attributes such as city, country, street number, and so on. So any attribute that we can split into multiple smaller attributes is called composite attributes. Okay. The third type of attributes is multi-valuated attributes. Okay, so the multi-valuated attributes is called like this because it have multiple values. What does this mean? For example, your email address, or you might have university email, but one student might tell me, but I have a personal email as well. So if you have multiple values and they both belong to emails, this is called a multi-valued attributes. So the multi-valued attributes can also be a phone number. If you have two phone numbers, then this could be a multi-valued attribute. So any attributes that has multiple value is called a multi-valued attribute. Okay. The last type of attributes is the derived attributes, and from its name, this attribute does not really exist in the database. However, we can calculate it whenever we need it. Think about which one of these attributes or columns inside the database I can get it even if I don't have it inside the table or the database. I can't really get your ID if you didn't tell me. I can't get your email. I can't get your name, and I can't get your date of birth. The only thing that I can calculate or get is your age. If I asked you about your date of birth, I can simply calculate how old are you. So that's why it's called a derived attribute. You calculate it. Another example of a derived attribute is calculating your overall GPA, for example. If I have columns that represents your grades in each single subject throughout university, I can derive from it your overall GPA, and so on. So any attribute that's not existing in the database but I can calculate it, I call it derived attribute. And it's represented by a dashed over shape. We're going to see how each type of attribute is represented inside the entity relationship diagram in the next slide. Okay, in the composite attribute, we draw new two oval shapes in order to represent the composition that formed this attribute. As for the multi-valued attribute, we draw double oval shape, just like this, for the emails. And finally, for the derived attribute, we draw dashed oval shape. Please memorize this, as you might be required to draw this in the exam with exactly the same symbols. You're not going to write anything in the diagram, you just have to draw it and it must be understood. Okay, so throughout this tutorial we discussed how to model data using an entity relationship diagram and how to draw different entities and represent the cardinality or the relationship between them and the different types of relationships that might exist between different entities. We also discussed the different types of attributes or columns that might exist for every single entity or single table inside the database. The last thing that we are going to discuss is primary keys. By this time, you should understand what does a primary key means from the lecture. However, for a quick recap, a primary key is any attribute or column that satisfies three conditions. First of all, it must be unique, which means it can never exist twice inside the same table. Second thing is, it can never have a null value, which means it can never be empty. The third condition is it can never change. Okay, the value inside this column can never change. Okay, so let's take this as an example. You, as a student, or a table that's representing some students. Which one of these attributes or column can satisfy the three conditions? Definitely, the date of birth of any student inside the university can happen many times. Same goes for the name. And same goes for the age. What satisfies the three conditions is the ID. You can never find a student with the same ID as you are. You always have a unique ID. Even if you changed the major, your ID will remain the same in the database of the university. Second thing, you can never change your ID throughout the university years. So the first condition is satisfied. You have a unique ID. Your ID can never change even if you change the major. And the last condition, you can never find a student with no ID, meaning the ID can never be null or empty inside the university database. So that's why ID is considered a primary key. And in the entity relationship diagram, we underline the word ID in order to state that this is the primary key that we selected. Okay, so this is the primary keys have different types. The first one is that it might be one attribute, and the second one, it might be multiple attributes together uniquely identify an entity. For example, I might take your ID and email together. However, in this case, one attribute is enough, because ID is already a primary key, so no need to make it a compound key. We make compound key when we can't find any single column that can identify uniquely each single instance inside this table, or each single row, or each single student. Okay. I hope you understood the concept of primary keys, how we draw them inside the entity relationship diagrams, the different types, and so on. Okay, so as we discussed primary keys, and again, we said primary keys are simply attributes inside the tables that uniquely identifies each record. After discussing the primary keys, the second thing that we need to have a look on is foreign keys. Before actually understanding what does a foreign key means inside a database, I would like you to think of foreign keys exactly as country's ambassador. So we're going to follow the example of country's ambassador throughout explaining what this a foreign key means. So please concentrate. I will definitely not ask you in the exam what does a country's ambassador do, but however, I will ask you what does a foreign key does. So in general, you just have to understand the concept in order to be able to write whatever you understand in the exam. So you don't have to memorize the theoretical things. You have to understand what this every single concept means, and from here you will be able to apply it. So, okay, let's start with our example in having country's ambassador. So, first of all, I'm just picking the pen instead of the laser pointer. Okay, let's take the first point, which is a foreign key is unique attribute that comes from another table in a database. What does this mean? Let's have this as an example on the country's ambassador. Imagine that Egypt and Germany, this is Germany. I'm sorry, the font is really bad, but the editor I'm using is really dumb. But anyway, so this is Germany and this is Egypt. And actually Egypt decided that it wants to make a relationship with Germany. Just like any country in the world, countries have to make relationships with each other. Just like as we explained in the entity relationship diagrams, tables make relationships with each other. So how does countries make relationship with each other? Simply by sending a foreign person who is German, but this person is not just foreign and coming from another country, he's also unique. Why unique? Because he's a diplomat and not just any other person who's just walking in the street. So that's why he's unique. And he's simply the ambassador. A foreign key actually works exactly like a country's ambassador, but how? A country's ambassador is simply responsible of representing his country. Why? Because if I really want to know information about Germany's hospital, people, and so on, and anything else, it doesn't make sense that I will have to talk to everyone in Germany and I will have to talk to all the hospitals in Germany and so on. So if I really want to have any information about Germany, all what I have to do is going to the ambassador and talking to this ambassador, and hence this ambassador can help me make relationship with any other entity or any other object inside his country. So simply the ambassador's role is to reference all the people inside his country. And accordingly, we can conclude that the ambassador joins or connects two countries together by this way. Okay, so this is the role of the ambassador. Same goes for the foreign keys inside the tables. For example, if I have a table inside the database, and I need to connect these tables together, or join, let's call it join. I said join exactly because actually join is the name of the operation that connects two tables together inside the database. How? Through not the ambassador and just like the countries, but in this case, the connection will be the foreign key. Sorry, I lost the pen. Okay, the foreign key. Okay, so we also said that the ambassador is unique because he's a diplomat. So same goes for foreign keys. Foreign keys must be unique. In case of databases, any attribute or column that we call unique, which means this attribute's values cannot be repeated inside a database, if you remember, is called what? Yes, exactly, a primary key. So if you were following up, a foreign key is simply an attribute, or not just a normal attribute, it's the primary key of another table. So we take this primary key, just like the ambassador, and we put it inside the other table and call it foreign key. So again, it's foreign because it's coming from another table, just like the ambassador, and it's unique because it can never be repeated. We can only find one ambassador per country. So it's the same. You can only find one value for this attribute inside this table, and that's why it's unique. And finally, the foreign key connects the tables together, just like the ambassador. I hope the example didn't confuse you, and I hope you understand it. In case you have any questions or you feel that you got confused, please feel free to ask me through the live questions and answers or through my email, and I will try to respond as soon as possible. Okay, so anyway, why do we use foreign keys and so on in real life and or in implementing databases? You will actually understand this practically through the databases course. But the concept behind this is exactly the same like the ambassador. How? I'm using foreign keys to get information from other tables instead of making connections with all the attributes inside this table or the columns. I just take the primary key, or just like the ambassador, I just take the primary key, put it in the other table, and call it foreign key. And through this foreign key, as it were, as it references everything in its original table, I can go to this table and know any other further information I want to know. So for example, if this table represents Germany and this table represents Egypt, I can know everything about the hospitals, the people, and everything through simply the ambassador or the foreign key. Okay, let's have another example on how this is actually represented inside the database schema in the next slide. Okay, before I start explaining where is foreign keys and where is primary keys inside this figure, I would like to tell you the name of this figure first. So simply, this figure is called database schema model. What is a database schema? Just like the entity relationship diagram, it's another thing that represents the structure of a database formally. So you can actually create a database schema using database management systems. So let me first explain to you the structure of database schema so that you can understand what I'm talking about. First of all, each rectangle represents a table inside the database. So this is a table for customers, and this is a table for the invoices made by the customers. And this is a table for line items, and I will tell you what is line items now, and another table inside the database for products. Okay, before moving on, let me first tell you what does line items means. Simply, I added these two screenshots to tell you what does line items mean, but you don't have to know anything inside them at all. You just have, it's just for you to understand what does line item means. So this is an invoice of McDonald's. I'm not sure why do I mention McDonald's a lot in this course, but anyway. This is an invoice for McDonald's, and here is the items ordered inside this invoice. Each line of these items is called a line item. So for example, in the line items table, you can find quantity. Here's the quantity. And there are two foreign keys, which are invoice ID and product ID. Ignore them for now. I will explain to you how does this work. But anyway, this is the line item. That's what I want you to know for now. And I took another screenshot from, I didn't take it, but I actually got it, but it's a screenshot from SAP system. And if you remember, SAP is simply an enterprise resources planning system. This is actually a screenshot from the original software that I told you you're going to use in the next semester in enterprise systems course. Anyway, ignore this, but this is how line item appears inside the system. So you can just find many items ordered, and then each line of these represents a single item or line item. Anyway, ignore this screenshots if you understood what this line items means. So I don't want you to focus on anything else in these screenshots. Okay, going back to the database schema model, we said that these are the tables. So we have 4 tables, and written inside them some data. Actually, these data, such as first name, customer ID, last name, city, they represent the columns inside the table. So if you're imagining this as a table, these are the columns, or again, a column inside the table is called an attribute. So these are the attributes of customers table, and these are the attributes of invoices table, and so on. So we can notice that one of these attributes is actually highlighted and underlined. So what do you expect this is? If I'm saying this is the only attribute that's highlighted, I will definitely think of it as something unique, which means that this is the primary key of the table, or the attribute that uniquely identifies each record inside the table. And this is the primary key of the invoices table, because invoice ID can never be repeated and customer ID can never be repeated. And same goes for line items. There are 2 attributes highlighted, and this is actually new for you. Can we actually have a primary key that consists of 2 attributes? Yes, and it's called compound key. So that's why two attributes are highlighted together, because one of them cannot really identify the line items. They must be both together. And anyway, the primary key of products table is simply the product ID. Okay, moving on, we explained the table, the attributes of the table, whereas the primary key. What's missing is the foreign key. Okay, as you can see, foreign keys are highlighted with FK letters between brackets, as you can see. So this is the foreign key, which means that we can infer that customer ID is actually an attribute, because it's foreign, that's coming from another table. So which table? Yes, customer tables. And we said that foreign keys are unique, therefore they must be primary keys. So this is achieved in the database schema, and you can find that the foreign key chosen for invoices is the primary key of the table customers. So that's actually how the table customers is linked to the invoices table. Why? For example, if this table has records for many invoices, for example, like this, and I want actually to know which customer ordered this invoice, I will just go to the customer ID and check it. So what if the customer ID is simply a number? What if I want to know the name of the customer? It doesn't make sense that I will have to repeat the customer name again in the invoices table. I can just take the customer ID, which is the foreign key, because it references all the information inside the customer tables. So I can just go and look for the customer's name inside the customer's table. So this is much easier to connect tables together in order to be able to get information instead of just repeating all the attributes again. This doesn't make sense. It will be time consuming, and again it will lead, if you remember, to redundancy or duplicates and inconsistencies. So simply the foreign keys can reference whatever information I want to get from here. So if I want to get the customer name, I will just go check the ID number and go to this table, go to the ID number. For example, if the ID number here in the invoice is 6, I will go to this table, find customer ID 6, and then see his first and last name and so on. I can also know his city, I can know whatever I want. Okay, so that's it for foreign keys and database schema. Again, if you feel that you're confused in anything, please let me know. I can re-explain whatever you want. Okay, so we are done for this tutorial, but I have one last thing that I want to say, which is I just want to give you a heads up on where are we right now in the tutorials according to the lectures and chapters. So we basically explained almost everything in chapter 5, starting from databases, business intelligence, Microsoft Access, which is an application on database management systems. And we also explained the entity relationship diagram, which is mentioned in chapter 5 and lecture 5. We additionally explained different types of keys and so on. So you actually have to know how to draw an entity relationship diagram because you might be asked to do so in the exam. And it was actually one of your assignments. I'm not sure if you're going to do it or not anyway. But even if you didn't do it in this course, you will do it in later courses in the exams as well, because it's actually important to understand. So yes, this is what we've done so far. What's missing in chapter 5 that we did not really cover is data mining and big data. I would like to make a tutorial on them both, but they need much more time in order to go through what does data mining mean and the different techniques inside data mining. So I'm not sure if we will actually have them in the next tutorial or not, but I promise I will try to include them in one of the tutorials at the end of the semester, because if we have time, for sure. So I will try to include them because they're actually fun to know, and data mining and data science in general is what everyone is talking about, and big data specifically is what everyone is talking about. So I want to have a tutorial on this because I think it's going to be fun for you. And not just fun, it's going to help you understand the two concepts of data mining and big data. You don't have to understand them in depth, but it doesn't harm to understand something deeply before going through it in next years. Okay, so that's what's missing in chapter 5. I also can solve another example on the entity relationship diagram. But this will be based on your requests because I'm not sure if the example explained in the tutorial is pretty clear or not. You can actually try to use entity relationship diagram tools to start drawing the diagram and ask me if you need any help. And in case many of you wants me to include this example in one of the next tutorials, to help you understand entity relationship diagrams better, please let me know and I will do this. So anyway, just let me know where do you need help and where you're fine, so that I can be actually giving you what you really need. That's it for today's tutorial. Thank you so much for listening, and see you next week. Goodbye.